Benjamin Franklin's electricity experiments and practical inventions remain some of the most fascinating chapters in the history of science, innovation, and human curiosity, because they reveal not only the mind of a great thinker, but also the spirit of a man who was determined to connect abstract ideas with everyday life and lasting benefit for society. Franklin, one of the most celebrated founding fathers of the United States, was more than a political leader, diplomat, and writer. He was a scientist, a practical inventor, and above all, an endlessly curious observer of nature who believed that the mysteries of the universe could be understood by patient study, bold experimentation, and a desire to apply knowledge for the greater good. In the mid-18th century, the study of electricity was still in its infancy, often regarded as a kind of parlor amusement or mysterious phenomenon that fascinated but confused many natural philosophers of Europe and the American colonies. It was in this atmosphere of curiosity and uncertainty that Franklin began his famous experiments. He had been intrigued by electricity as early as the 1740s, when reports of strange effects, sparks, shocks, and glowing tubes began spreading across Europe from experimenters like Peter van Maschenbroek of Leiden, who created the Leyden jar, an early device capable of storing an electrical charge. Franklin, always eager to explore, obtained some of these devices and quickly began experimenting in Philadelphia. His approach was different from many of his contemporaries because he sought not only to observe the curious effects of electricity, but also to classify, explain, and ultimately harness it for useful purposes. One of Franklin's earliest contributions was his theory of positive and negative electrical charges. He proposed that electricity was a single fluid that could be transferred from one body to another, and that when a body had an excess it was positive, and when it had a deficit it was negative. This idea, though simple in phrasing, provided clarity in a field otherwise filled with confusion, and remarkably, his terminology of positive and negative charge has survived to this day. Franklin's curiosity drove him further. He wondered if lightning, that awe-inspiring and dangerous force of nature, was itself a form of electricity. It was an audacious question at the time, because lightning was still viewed by many as a mysterious or even divine phenomenon beyond human understanding. Franklin, however, hypothesized that the sparks generated in his small-scale experiments with Leyden jars and static machines were of the same essence as the flashes of lightning that split the skies during storms. To test this, Franklin devised a series of experiments, the most famous of which became legendary in American and scientific history: the Kite experiment of 1752. In this bold demonstration, Franklin, accompanied by his son William, launched a simple silk kite into the stormy skies of Philadelphia, attaching to it a metal key and a thin wire to collect the atmospheric charge. As the thunderstorm raged, Franklin observed that the fibers of the string stood out, and that when he touched the key with his knuckle, he felt the unmistakable shock of electricity. This confirmed beyond doubt that lightning was indeed an electrical phenomenon. The success of this experiment was a turning point in the understanding of natural forces and earned Franklin international acclaim, placing him among the foremost natural philosophers of his time. Yet Franklin did not pursue these discoveries merely for personal fame or intellectual satisfaction. His genius lay in linking abstract science to practical invention. Realizing the destructive power of lightning and the danger it posed to homes, barns, and churches, Franklin invented the lightning rod, a simple but revolutionary device consisting of a metal rod mounted atop a building and connected to the ground by a conductive wire. By providing a safe path for lightning to travel into the earth, the rod prevented countless fires and saved property and lives. This invention quickly spread across the colonies and Europe, establishing Franklin as a man whose experiments were not only bold, but also deeply useful. Franklin's electricity work also inspired him to coin terms still in use today, such as battery, conductor, charge, discharge, and electrician, helping to establish a new vocabulary for the emerging science. His writings on electricity, compiled in his Experiments and Observations on Electricity, were translated into multiple languages and influenced scientists like Joseph Priestley, Alessandro Volta, and Michael Faraday, whose later work built upon Franklin's foundations. Beyond electricity, Franklin's inventive spirit continued in other areas. He believed that knowledge should serve human needs, and thus many of his inventions were practical, designed to make daily life easier or healthier. He invented the Franklin stove, an efficient heating device that used less wood and provided more warmth than traditional fireplaces. Though he declined to patent it, wanting it to benefit as many people as possible, it became widely adopted in colonial America. He also created bifocal glasses, inspired by his own struggle with both near and far-sightedness, enabling wearers to read and see at a distance without constantly changing spectacles. Another creation was the glass armonica, a musical instrument consisting of spinning glass bowls of different sizes that produced haunting, ethereal tones when touched with wet fingers. Though it later fell out of fashion, in Franklin's day it captured the imagination of composers like Mozart and Beethoven. He designed an odometer to measure the distance traveled by his carriage, a flexible urinary catheter for medical use, and even improvements in swimming fins, reflecting his lifelong love of swimming. In every case, Franklin's inventions displayed his characteristic blend of curiosity, practicality, and generosity, for he rarely patented them, believing that discoveries were gifts to humanity. His work with electricity, however, remained his crowning scientific achievement. It was not without risk, as he himself cautioned others against repeating the Kite experiment due to its potential danger. And indeed, some who attempted it were fatally struck by lightning. Yet Franklin's careful execution and insightful conclusions transformed electricity from a curiosity into a serious field of natural philosophy. His recognition that electricity could be tamed, studied, and applied set the stage for the technological revolutions of the 19th and 20th centuries, from telegraphy to electric power and beyond. Franklin's legacy in this domain is immense. When he traveled to Europe, he was celebrated not only as a colonial statesman, but as a scientific hero, honored by the Royal Society of London and corresponding with leading thinkers of his age. Voltaire himself hailed him as the modern Prometheus who had stolen lightning from the heavens and given it to mankind. Such admiration reflected the extraordinary impact of a man who had no formal scientific training, but relied instead on relentless curiosity, practical reasoning, and hands-on experimentation. His experiments also reinforced his Enlightenment ideals, the belief that human reason and science could unlock the secrets of nature, improve society, and expand liberty. For Franklin, science was not isolated from politics or philosophy. It was part of the same pursuit of knowledge, freedom, and progress. He once remarked that he never made an invention for gain, but always to serve others, embodying his civic spirit. As we look back on Benjamin Franklin's electricity experiments and practical inventions, we see not only the story of one man's brilliance, but also a broader narrative of human advancement. In his hands, lightning ceased to be a terrifying mystery and became a subject of study, explanation, and protection. In his workshop, everyday challenges inspired devices that improved health, comfort, and efficiency. In his writings, new concepts were given names and clarity. And in his character, science and public service merged into a single philosophy of life. Franklin's legacy teaches us that true genius lies not in the possession of knowledge, but in its application for the benefit of all. His work foreshadowed the modern world in which electricity would become the lifeblood of civilization, powering homes, industries, and technologies undreamed of in his day. Yet the roots of this transformation trace back to the stormy skies over Philadelphia, where a man with a kite, a key, and an unshakable curiosity dared to prove that the heavens themselves could be understood by reason and experiment. Benjamin Franklin's electricity experiments and practical inventions remain a testament to the boundless power of human curiosity, the courage to question, and the commitment to use knowledge for the common good, ensuring that his legacy endures not just as a founding father of a nation, but as a founding father of modern science and invention.